right, so we've been talking about polygons, so today we're going to talk very deeply about one type of polygon called a triangle. You know all about triangles. You learn them in 5th grade, you learn them in 6th grade, and you're reviewing them really in 7th grade. So when we classify triangles, and I always like to think about classifying like a filing cabinet. So if I have filing cabinet drawer open with folders in it, and I'm talking about triangles, I'm going to have 2 folders. One folder is going to be, I'm classifying those triangles by their sides, and the second folder is going to be by their angles. So we have 2 ways to classify. By the sides and by the angles. And you've done this before, I know you have. So if we're going by the sides, we can call it scalene if no sides are the same. No sides are congruent. It would be scalene. We can do isosceles. 2 sides are congruent. And we can do equilateral. Equilateral, 3 sides are congruent. So if I was drawing these, the scalene, it's really hard to draw a scalene. And then an isosceles, and notice those tick marks. This one doesn't have any, so even though these 2 sides look like they could be the same length, they're not. And an equilateral would look like this, with a tick mark on every single side. Now, that's one way I can classify. Then I can classify triangles by their angles. An acute triangle is very, very cute because all of its angles are under 90 degrees. So, all angles less, all angles less than 90 degrees. The next type is the obtuse triangle. And the obtuse triangle is going to have one angle that's above 90. So one angle greater than 90 degrees. And then the last type is a right triangle, which has one angle which is equal to 90 degrees. I have one more to add here now, which you probably have never done before, and it's a reflex angle. And a reflex angle is, a reflex, you know what, I'm not going to do that here. I'm not going to do it with triangles. I'm going to wait and do it with angles. Okay, so if I wanted to draw an acute triangle, an equilateral is a great example of an acute triangle. If I want to show that all 3 angles are the same, I do a little curvy mark like that on each angle that shows that they are the same. An obtuse angle or triangle has one angle that's bigger than 90. So that would be this one, and that would be obtuse. A right triangle looks like this, and I know it's right because I'm going to put a box there. This side might be equal to that side. It could also be isosceles, but it doesn't have to be. All right, so that's how I classify triangles. Now I'm going to do some things with triangles. The first thing I'm going to do is find the perimeter of a triangle. Perimeter is very easy on a triangle because you add up all the sides. So if I have a triangle that looks like this, and I say this side is 12, this side is 8, and this side is 4, I'm going to do 4 plus 8 plus 12. And I will get 24, whatever the units are. Let's say it's inches. I don't square it or anything. I just keep it as inches. Okay, area of a triangle is also something that you've done before. Area can sometimes be tricky because even though you know the formula, 1/2 the base times the height, which can also be written base times height divided by 2, either way means the same thing, you have to know where the height is and where the base is. So it's very easy if you have a right triangle, right? Because here's the height and here's the base. What happens when you have an equilateral triangle? You can't have the height be slanted. Would I be the right height if I was like this? No, I wouldn't. You couldn't measure my height that way. So you have to measure the height from a vertex perpendicular to the base. So this is the base and this is the height. And then the third type would be an obtuse triangle, which looks like this. Again, I can't measure the height like this with a slanted line, so I have to measure it with a dotted line. Here's the height. It's going from the vertex perpendicular. Is that perpendicular? Probably not from my angle. And then, so this would be the base. Okay, actually, you could do it that way, or you could do it this way. You could draw a height out here. Sometimes you'll see it this way, sometimes you'll see it this way. This would be the height, and then the base would only be this part, not all the way out. So either way works perfectly fine. Okay, thank you.